You saw the headline, "New global images are out and NASA's leadership just changed." Here's why that matters to where you cast this weekend. If you've been chasing fish by reading only the surface, wind, birds, tide, you're missing the bigger map. Think of these satellite views as the weather report for fish highways. Stick with me. I'll show you how to use large-scale temperature breaks and current lines, exactly the kind of data behind these new images, to pick a launch spot with confidence. One screen, one clue, fewer empty drifts. Let's dive in. Before we move on, I'd like to ask you a small favor. If you appreciate this content, please take a second to like this video and subscribe to the channel. Over 98% of you watch the videos without subscribing. It costs you nothing, but it makes a huge difference to us. So, did you click the subscribe button? Great! Thank you so much. Now, back to the video. You scan the bay. Birds dip. Slicks shine. The surface looks right, but the bite is flat. Yesterday, the stack was 20 miles out. You didn't miss the fish, you missed the road they took.
These jets are naturally produced out of ice on the surface of a rock. And the second possibility is that they might be thrusters on the technological spacecraft.
We've got some updates. Check out these new images that show the 3i Atlas in a whole new light. What's going on with this situation? Where are these jets?
Even after it passed through perihelion, it was heated by 770 watts per square meter. And we know that the previous plume of gas was mostly carbon dioxide.
The satellites watched the road all night. Large-scale temperature breaks and current edges run like highways across the sea. Bait rides the flow to save energy. Predators follow the bait because the buffet lines up along those edges. Out on the water, your eyes read signs. On the screen, the map shows the route. Use both, but start with the route. Here's the snag. The warm cool edge that fed your bay at sunset slid while you slept. A wind shift and a push of current nudged that line offshore. Life moved with it. So at first light, your spread swims in empty water even though the surface still looks alive. Think of it this way, the global map is your highway map. Your on-the-water reads are the exit signs. Exit signs help only if you're on the right road. The trick is to get on the road first. Why do edges win? Gradients, the quick shift in temperature, create skinny zones where plankton gathers. Chlorophyll fronts mark that food. Current convergence lines tighten it up. Plankton stacks, bait piles into feed, and gamefish stack on the bait. It's a chain. A narrow 1 to 2 degree break that hugs a seam often beats a big warm bowl with no edge. The edge is the event. Average water is background. Remote sensing pulls out the stuff you can't see from the dock, eddies that spin, thin filaments that peel off, river plumes that bend a path days ahead of your launch. Those shapes set where fish land. Do this before you hitch the trailer.
Well, thanks for having me. We see more than 7 jets that are tightly collimated coming out of this object. And of course, there are 2 possibilities that we considered all along, that by the solar radiation and the solar wind, but we don't see that. So the question is, what's going on? One possibility is that what evaporates from it are fragments of ice, and they get vaporized by sunlight. So what I'm saying is, you know, there are things we don't fully understand about this object. That's what makes it exciting, and I think all of us will wait for the data that will come in the coming weeks.
Open a global SST layer and an altimetry view. Scan for the tightest gradient in your range. Drop a mark on the cleanest line. Pick the launch that cuts the least dead water. Fuel for that route. Start with the front, not the dock. One screen. One clue. Fewer empty drifts. Next up, let's make those edges sharper and talk about what new eyes in space, and a leadership change, mean for your data stream. If the front is your clue, you want that line crisp, daily, and wide. China's new passes add more sweeps over the same water and a broader look at sea surface texture. That means you see temperature edges and current shape more often between trips, so plans don't go stale while you work or sleep.
And so how do we tell the difference? Well, if it's a natural object, then we know the temperature on the surface of a rock, given its distance from the sun, and then carbon dioxide ices can sublimate at a much lower temperature than water ice. So we should have seen it break up, or at the very least disintegrate to a very dense and massive cloud of gas and dust that is pushed away from the sun.
Is it streaming out? What is all this? Is it breaking up after possibly going behind our sun? A little confusing because this all comes after last week images showed the object with no tail. Weird.
More data sounds great, but you care about what lands on your phone. Anglers worry about paywalls, odd file types, or delays when policies change. That's fair. The trick is to know what you actually use. You don't pull raw satellite strips on deck. You use composites, model blends, and overlays that turn raw scans into clean edges and arrows. Those tools sit downstream of the spacecraft and handle format changes for you. Here's where the upgrade helps you. When one feed hits cloud, a second set of eyes fills in the gap. Blend stack passes so the contour of a 1 to 2 degree break stays tight and the current line stays visible. You get fewer jagged holes in the map, more continuous edges, and a cleaner route to mark. Say yesterday's view was a wash of cloud over your target zone. With another constellation in the mix, today's board still shows the front, so you keep the track you drew instead of guessing. That keeps fuel and daylight on your side. Now about leadership shifts. Big agencies review priorities when the nameplate changes, but long-running Earth-observing work tends to carry on through those cycles. Continuity rules the pipeline because shipping daily maps to farms, ships, and weather desks depends on it. That said, you hedge the small bumps. Do this. Bookmark more than one source. Set simple alerts for front motion in your range. Cross-check your edge the night before and again at launch. If one site lags, the other fills in and you still roll on plan. Your upgrade is steadier, sharper edges with fewer blind spots. Headlines come and go. Redundancy keeps your route clear. You now have the highway map and a steadier signal, time to act on it every time you gear up. Fish follow edges. Satellites draw the lines. Use the big map first, then read the surface when you're out on the water. Start with the highway, then watch the exit signs. That's the trick. Before your next run, open a global SST and current front layer. Find one tight edge in range. Drop a mark. Plan your first drift right on that seam. You'll save fuel and time, and your spread will swim where life stacks. If this helped, subscribe and come back for more trips and tips. We'll keep turning space data into clean, simple moves you can run from dock to drift.